Hi, my name is Yihui Ye, and here's the solution for homework 2, problem 2. So the problem A is to find the probability that x2 equals 1. From given condition, let k equals to 1. Then we can get the probability that x2 equals 0, 1, x1 equals 0 equals 0.6. And the probability that x2 equals 1 when x1 equals 0 equals 0.4. And the probability that x equals to 0, 1, x1 equals 1 equals 0.3. And the probability that x2 equals 1, 1, x1 equals 1 equals 0.7. So to calculate the probability that x2 equals 1, we know the probability that x1 equals to 0 equals to 0.2, and the probability that x1 equals 1 equals to 0.8. And also the probability that x2 equals 0, 1, x1 equals 0 or 1. Then we can get the probability by the equation P. The probability that x2 equals 0 equals the probability that x2 equals 0, 1, x1 equals 0 times the probability that x1 equals 0 plus the probability that x2 equals 0 when x1 equals 1 times the probability that x1 equals 1. So saying we can obtain the probability that x2 equals 1 by the equation P x2 equals 1 when x1 equals 0 times P x1 equals 0 plus P x2 equals 0 when x1 equals 1 times P x1 equals 1. So by using matrix, we can calculate the result easily by the equation P x2 equals 0, P x2 equals 1 times P x2 equals 0, 1, x1 equals 0, P x2 equals 1 when x1 equals 0, P x2 equals 0, 1, x1 equals 1, P x2 equals 0, 1, xy equals 1, which equals 0.2, 0.8 times 0.6, 0.4, 0.3, 0.7 equals 0.36, 0.64. Then P and the probability P that x2 equals 1 equals 0.64. Let's look at the problem B. To find the probability that x3 equals 1, let k equals 2. Then we can get the probability that x3 equals 0 when x2 equals 0 equals 0.6. P x3 equals 0 when x2 equals 0 equals 0.4. P x3 equals 0 when x2 x2 equals 1 equals 0.7. We already know the probability that x2 equals 0 and the probability that x2 equals 1. So as the problem A, we can calculate the probability that x equals 0 and x3 equals 1 by the equation 0.36 0.64 times 0.6 0.4 0.7, which equals 0.408 and 0.592. So probability that x3 equals 1 equals 0.592. So problem C, to calculate the probability that x1 equals 0, 1, x3 equals 1. We can express it using p x1 equals 0, x3 equals 1 over p x3 equals 1, which equals 2 and p x3 equals 1 when x1 equals 0 times p x1 equals 0 over p x3 equals 1. Then we need to get p x3 equals 1 when x1 equals 0. So we already know the matrix of probability related to x2, x1, and the matrix of probability related to x2 and x3. So the production of these two matrices is the matrix p x3 equals 0 when x1 equals 0, p x3 equals 1 when x1 equals 0, p x2 equals 0 when x1 equals 0, 2 p x2 equals 0 when x1 equals 0. Oh, sorry, this is x3. Equals 0.6, 0.4, 0.3, 0.7 square, which equals 0.48, 0.52, 0.39, and 0.61. Then we can get p x3 equals 1 when x1 equals 0 equals 0.52. So the probability that x1 equals 0 when x3 equals 1 equals 0.52 times 0.2 over this one, 0.592, which is 0.176. Okay, so here's the problem D. So to find the limit pxn equals 0, 1 x is infinite, we need to calculate px infinite equals 0, px infinite equals 1 from the above solution. So we can get this one equals to limit 0.8 times the matrix 0.6, 0.4, 0.3, 0.7, and to the n's when n is infinite. So let's assume when n is infinite, pxn equals 0, pxn equals 0 equals to pxn minus 1 equals 0, px1 minus 0 minus 1 equals a and 1 minus a. So from the equation we can get a 1 minus 0 times 0.6, 0.4, 0.3, 0.7. And this one we choose the px n minus 1 and p equals 0 and pxn minus 1 equals 1 equals a 1 minus a. Then we can get 0.6a plus 0.3 times 1 minus a equals a. So a is 3/7. Therefore, the limit pxn equals 0 when n is infinite equals 3/7.